everyone. Today we are going to continue solving for the solutions of a polynomial, and we will be using long division and synthetic division instead of factoring. So we'll start with factoring just as a quick review, and then we'll move into long division and synthetic division, and at the end we will cover the remainder theorem. So let's go over this quick factoring question. We want to find out what multiplies to positive 3 and then adds to negative 4. And so we want two binomials. We need a negative 3 and a negative 1. And then we're going to have x squared for both. And so then when we solve this, we get x squared minus 3 equals 0, x squared minus 1 equals 0, and x squared equals 3, x squared equals 1. X will equal plus or minus the square root of 3 and plus or minus 1. So we want to keep it square root 3 as the exact answer and not look at the decimals because exact answers are going to be better answers overall. So what that looks like graphically is we have our 1 and negative 1. We call those rational roots because they can be written as fractions and they simplify. And then we have these other two values, which are the negative square root 3 and positive square root 3. And so those are actually called irrational roots. And so if you were to have solved this by graphing, you would not have been able to see that what the actual exact answer was for the irrational roots. So we have to solve by factoring to get those, and that's not always going to be possible. So that's what we're going to focus on today's other methods for solving besides just factoring. So let's look at this first example. Let's try to solve it by, first we know there's going to be 3 total roots, and we already know by looking at the graph that x equals 0. That's our one rational root. But if you look at that graph, it's hard to tell what the exact value for the other two zeros is. And so what I want to try is let's try factoring. Let's take out the x and write what's left over, x squared plus 4x minus 3. But what you should notice now is that you can't factor x squared plus 4x minus 3. Nothing multiplies to negative 3 and adds to 4. So I'm going to write unfactorable, which is what gives us our two irrational roots. And so that is unknown to us right now. We're going to put some question marks in there. And then what we want to do is figure out what can we do then to get those irrational roots. It should be something that you've learned before. If you can't factor a quadratic, then what do you do? So let's go back to these steps. We already did the first step, factor out the x, but I want to add a note that that's also called dividing by when you factor something out. You're dividing by that value. And so I want to keep that vocabulary there, divide by, because we'll use that later. And then just think for a second, what do you do to solve for a quadratic when you can't factor it? All right, if you thought quadratic formula, then you were correct. And so the quadratic formula, in case you forgot, is negative b plus or minus square root b squared minus 4ac all over 2a. And so we have a equals 1, b equals 4, and c equals negative 3. We will do that now to solve for the remaining two roots. B squared minus 4ac all over 2a. Let's simplify inside that radical. That's going to get us 16 plus 12. And then we're going to simplify this radical. We are going to find the biggest perfect square factor, which is 4. Square root of 4 is 2, and we'll have 7 left over. 4 times 7 is 28. And finally, we will simplify this, divide everything by the 2. And those are our two irrational roots. And don't forget the 0 for the third root. Remember, there were 3 roots total. And so that's how you get all of the roots when you can't solve by factoring and you can't see the values on the graph. Okay, Okay, so let's look at this next one. X cubed plus 5x squared minus 18x plus 8. First thing is, if we try to factor, we can't use the grouping method because we don't have the same ratios in the first two terms as we do in the second two terms. 1 to 5 and 18 to 8 are not the same. We do know that there are 3 total roots, so what we would do is graph this in Desmos. I've already done that for you, and so you can see that graph right here. What we want to find next is our one rational root, as we can see it right there. It's x equals 2. And those 2 blue ones I highlighted are values that we can't tell from the graph, but we know that they are real because we can see them on the x-axis. We're just going to call them irrational, and we want to solve for the exact value. And we'll again want to use the quadratic formula. But we can't get there as easily as we could last time. We can't just factor out x minus 2 because we don't know what's going to be left over. We do know x minus 2 is a factor because it is a root, as you did extensive practice with roots and factors yesterday. So what we want to do is divide it out like we did a few steps ago, and then use the quadratic formula. So what we're going to do is start with long division. That's the only thing we can do right now, is to divide out this x minus 2. And before we get into it with variables, I just want to quickly review long division with numbers. This is a reminder for how to do it. So remember when we started with a long division, we've never done that in here, but when you started learning long division, you would do it for numbers like this. And the process was, what can I multiply 6 by to get a number that's less than 47 that I can subtract? And so 6 times 7 is 42, or we ask ourselves, how many times does 6 go into 47? The answer is 40. The answer is 7 times. And we multiply the top number by the outside number, and we get 42, and then we subtract. 47 minus 42 is 5, and then we bring down this 2. Well, then we'll repeat the process. How many times does 6 go into 52? This time that's 8. 6 times 8 is 48. Now we subtract, bring down, or write the answer 4. And there's nothing to bring down. So we could, put a decimal and keep going, but we're not dealing with decimals with these polynomials, so we're not going to worry about that here. What we could say is this is the remainder. And we could write it like this, 4 over 6, which is 78 and 2/3. Or we could say 78 with a remainder of 4. But you also can just put the remainder over the divisor out there. So we're going to use that exact process to divide with polynomials. So on this page, I have it set up for us that we're going to divide x cubed plus 5x squared minus 18x plus 8 by x minus 2. So I want to follow the same kind of steps. So let's see how we do that. First, we need to, I wrote the steps onto the side, but remember, how many times does x minus 2 go into x cubed plus 5x squared minus 18x plus 8? The way we figure that out is we just think, what multiplied by x will get us x cubed? And that would be x squared. We write that on the top. And then we multiply all of x minus 2 by that. So x squared times x is x cubed. And then x squared times negative 2 is negative 2x squared. And then we do the same thing we would do if these were numbers. We subtract this from the polynomial. So it's x cubed minus x cubed will cancel. 5x squared minus negative 2x squared becomes 7x squared. And then we would bring down the rest. Now we repeat the process. What multiplied by x will get us 7x squared? That would be 7x, positive 7x. So I go ahead and write plus 7x. Then we multiply all of x minus 2 by that. 7x times x is 7x squared. 7x times negative 2 is negative 14x. And then we subtract. So that cancels. That's always the goal, is to cancel that first term. The negative 18x minus negative 14x is negative 4x. Remember, it's minus a negative. Well, you'll be adding it. And then we repeat one more time. What times x is negative 4x? That's negative 4. So negative 4 times x, negative 4x, negative 4 times negative 2, positive 8. And we'll subtract that whole thing. So negative 4x minus negative 4x cancels, and then 8 minus 8 is also going to cancel, leaving us with a remainder of 0, which we should always get a remainder of 0 when we divide a polynomial by its factors. So I just want to show you, this is our first step. I'm going to highlight it in blue. Then we multiplied all of x squared by that to get this. All of x minus 2 by that. Then we subtracted. Make sure you always subtract. And then we repeated until we got the final answer with a remainder of 0. Or any other remainder. So if we had gotten any other number, we would have stopped there as well. So now we know that x cubed plus 5x squared minus 18x plus 8 divided by x minus 2 is x squared plus 7x minus 4. And so I have actually, it's just like factoring it. Now I know the two factors are x minus 2 and x squared plus 7x minus 4. So we will finish solving. Again, I know x minus 2 equals 0, x equals 2, x squared plus 7x minus 4 equals 0, and I'll use the quadratic formula to solve that. Okay, so 49 plus 16, let's see, what is that? 65. And 65, the only thing that is 13 times 5, which neither of those are perfect squares. And so we have our 1 rational answer and our 2 irrational answers right here. 1, 2, 3 total roots. So if I was to type -7 plus square root of 65 all over 2, I would get this little value right here on the right. And if I were to do minus, I would get that one on the left. Okay, let's move along to another type of dividing. So we did long division. It's called long division because it's, a long way to do it. So let's do a faster way. It's called synthetic division. Synthetic means fake, but it works. So when we divide by a linear factor, we can use synthetic division to get the quadratic more quickly. And so we have the same problem. I don't want to get us too complicated. I'm just using the same problem. And so we're going to follow these steps on the right. First thing we do is we set the thing we're dividing by equal to 0, and then solve for x. And so we know x equals 2. That also represents the 0. We already know, we could see it from the graph. X equals 2 is the 0 on the graph. And so that's why I put the 0 in the box. And so I make a little box, or I write 2, and I draw a little box around it. Next thing we do is write the coefficients in descending order. If there's any skipped terms, we'll put 0 for that one. So we'll start with 1x cubed plus 5x squared minus 18x plus 8. If there are any skipped values, I would have put 0 for those, like if there was no x squared. Then I put a little arrow for bringing the leading coefficient down. Whatever number is in that first spot comes down below the line. And then we just multiply by the 0 and put it in the next spot, add until we get to the end. So I'm going to do 1 times 2 is 2, 5 plus 2 is 7, 7 times 2 is 14, -18 plus 14 is -4, and -4 times 2 is -8. And I like to box that remainder off, and so stop there. The numbers we get at the bottom are the new coefficients for a polynomial with 1 degree less than the original. So we have 1x squared plus 7x. We'll go down in descending order just like we did to start with, equals 0. Well, we don't have to put that equals 0. That's our factor, our other factor. So let's just go through these steps one more time. First thing is we have our 0 in the box. That x minus 2 became 2. Then we write our coefficients in descending order. So that was here. 1x squared, 1x cubed, 5x squared, -18x, and 8. Then we brought the LC down. So that was right here, this little step. And then we multiply and divide. So we multiply, add, multiply, add, multiply, add till we get our remainder of 0. And that is right here. Okay, So that's just a quick overview of how that works. So same thing, we would finish solving. We've already done this, so I'm not going to do it again. We now know that x equals 2 and that x equals, I think it was -7 plus or minus square root 65 all over 2. So our 3 rational roots. Okay, our 3 total roots, 1 rational, 2 irrational. So let's just do a quick example from beginning to end so that we can make sure that we know how to do this. And so let's get going there. We have x cubed minus 2x squared equals 14x minus 3. So first step is to make sure this is always equal to 0. It's got to be equal to 0. And so I'm going to subtract the 14x and add the 3. And then we will graph it. I've already done that for us. We can see here our zeros. We have one right here at -3, and then we have one right here and one right here that I can't tell what they are from the graph. Remember, you can click on these zeros in Desmos to see what they are, and you'll see that the 2 on the right are never-ending decimals, which is how we know they're irrational. So we found one real rational zero, x equals 3. And remember, we know that a factor would be x minus 3. Oops, I've done this before. X equals -3. So as a factor, we know that would be x plus 3, but we don't need to actually look at it as a factor. We already have the 0. So now we'll use synthetic division to reduce it. Put the -3 or the 0 in the box. Write the coefficients when it equals to 0 in descending order. And bring the leading coefficient down, multiply, and add until you get to the end with 0 as your remainder. 0 will always be your remainder when you use a factor as the, when you use a root or the factor in the box, and so that's how you know if you made a mistake. Write the coefficients with the new polynomial, and then we will solve this with the quadratic formula. So let's finish this up. 5 plus or minus square root 21 all over 2, and then we also have our other factor, our other 0 of -3. So those are our 3 answers. Okay, so that's all we're going to do for solving. We have long division, synthetic division are 2 tools that we can use to solve polynomials. And now we'll just have one last thing to cover, which is the remainder theorem. So it's just a quick definition. The remainder theorem says that when you divide a polynomial p of x by a linear expression x minus a, that you get the remainder, let's put that here in purple, is the same as if you were to just plug that value in to the function. So here's a quick example. We're going to use synthetic division to do this because 2x minus 3 is a linear factor. So remember, we set 2x minus 3 equal to 0. That means x equals 3 halves. So I'm going to put 3 halves in my box. I'm going to write the coefficients 1x cubed, 0x squared, -2x, and 1 here. Bring the leading coefficient down, multiply, add, multiply, add. Let's see, that's going to be 1/4. And then multiply, that's going to be 3/8, and then we'll add. This is our remainder, 11/8. If we were to plug in 3 halves to the function and do 3 halves cubed minus 2 times 3 halves plus 1, we would also get 11/8. They're the same. So the next thing says if the remainder when dividing by x minus a is 0, then x minus a is a factor of p of x. So when you get 0 in the box, it's a factor or a root or whatever you want to call it. X minus a is a factor, a is a root, etc. Okay, so let's look at 2 last examples. Why don't you guys pause the video and try these two examples, and then we'll go over the answers when you unpause. Set that equal to 0, x equals -1, 3, 2, 1, -1. Bring it down, multiply, 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 and add. So we bring it down, multiply, add, multiply, add, multiply, add, and then that's our remainder, and so -3 is the answer. Is x minus 4 a factor? So we set that equal to 0, x equals 4, we'll put 4 in the box, and then we have 2x cubed minus 9x squared plus 9x minus 20. Bring the 2 down, multiply, add, etc. And we got 0 as the remainder. So yes, x minus 4 is a factor. All right, so now you guys are going to, that is it for today. And so we will pick back up tomorrow practicing this, and then you'll have an assignment to practice tomorrow during class, and we'll move on to complex zeros. Hope you guys all have a great day. Thank you so much for paying attention and listening, and enjoy the rest of your day.